The Maclaurin series for the function f of x equals 1 plus x to the power of r for any real number r is known as the binomial series. If the absolute value of x is less than 1, it converges to f, and we can write 1 plus x to the r equals the sum from n equals 0 to infinity of r choose n times x to the n. This equals 1 plus r times x plus r times r minus 1 over 2 factorial times x squared, and so on, until plus the product of the quantities r times r minus 1 and so on, out to the quantity r minus n plus 1 over n factorial times x to the power of n, plus etc. Let's use this for an example. Find the binomial series for f of x equals 1 plus x all to the negative 3. Referring back to the previous equation, we see that r equals negative 3. Substitute r into the equation and we have 1 plus x to the power of negative 3 equals 1 plus negative 3 times x plus the quantity negative 3 times negative 3 minus 1 over 2 factorial times x squared plus the quantity negative 3 times negative 3 minus 1 times negative 3 minus 2 over 3 factorial times x cubed, and so on until plus negative 1 to the n times 3 times 4 times 5 and so on times 3 plus n minus 1 all divided by n factorial and multiplied by x to the n. We can now write the solution in a general form of 1 plus x all to the negative 3 equals 1 plus the sum from n equals 1 to infinity of negative 1 to the n times 3 times 4 times 5 and so on times 3 plus n minus 1 all divided by n factorial and multiplied by x to the n. For this example, we want to find the first three terms for f of x equals 1 plus x all to the 1/3. Referring back to the binomial series, we see that r equals 1/3. Substitute r into the equation and we have 1 plus x all to the 1/3 equals 1 plus 1/3 x plus the quantity 1/3 times 1/3 minus 1 over 2 factorial times x squared plus the quantity 1/3 times 1/3 minus 1 times 1/3 minus 2 over 3 factorial times x cubed, and so on until plus negative 1 to the n minus 1 times 2 times 5 times 8 and so on times 3 times n minus 1 minus 1 all divided by 3 to the n times n factorial all times x to the n. We can now use this to find the first four terms of the series. This gives us 1 plus 1/3 x minus 1/9 x squared plus 5 over 81 x cubed.